My name is Henderson, and today I'll be talking to you about elastic collisions. So first of all, you can't talk about physics unless you talk about Newton's 3 laws. If you do physics, you have to live and die by these 3 laws. So the first law is an object in motion tends to stay in motion unless acted on by an outside force. And it's also true vice versa. An object at rest tends to stay at rest unless it's acted on upon an outside force. The second law is just simply stating that force is equal to mass times the acceleration. And that's true for any bit of matter in the universe. And law number 3 is the law of conservation, where Newton states that energy is neither created or destroyed, it's simply transferred between matter, which leads us into our next subject. What is an elastic collision? Now there are 2 types of collisions. There's an inelastic collision and there's an elastic collision. In an elastic collision, 2 particles or 2 objects will collide together, and when they collide, the kinetic energy will simply be transferred in between them so that no kinetic energy will be lost. So with that being said, we're going to go to the conservation of momentum. Now this equation may look difficult. There's a lot of numbers and letters, subscripts, but I'm going to break it down to you. It's going to be pretty simple. And it's all color coordinated so that you will be able to go back and look at it. So now we're going to talk about the conservation of momentum, which is stated in this equation. Ma1 times Va1 plus Mb1 plus Vb1 is equal to Ma2 plus Va2 plus Mb2 times Vb2. Now this may seem confusing, but it's not really that confusing. M stands for mass. V stands for velocity. A stands for ball A. V stands for ball A, or object A. 1 stands for before the collision. 1 also stands for before the collision. And it's the same thing on the other side. Ma2 stands for the mass of ball A after the collision. 2 means after the collision. Mb2 stands for the mass of ball B after the collision. A little hint. Your M's, Ma2, Mb2 is the same thing as Ma1, Mb1 because we said matter is not destroyed. So the mass of the balls or the objects after the collision will always be the same. So that narrows it down. The only things that are going to change are the velocities. So right here I've broken it down into diagrams for you to understand. So this whole left side of the equation stands for the momentum of the balls before the impact. This whole left side. So this is a visual description of this, and I have it color coordinated. So this is ball A, and it has a mass of A, which correlates to this, red, red. It's traveling in this direction at a certain speed, meters per second, which is velocity of A1, velocity of A1, velocity of ball A before the impact. Same thing with this. Pink represents the mass of ball B before the impact, and V represents the velocity of ball B before the impact. Now, these 2 balls are going to impact each other. And when they impact each other, there's going to be a split segment where there's no energy. All energy is being transferred and is being converted to potential energy. For 1 split second, these balls right here are going to almost stick together. Elastic. Ball A is transferring its energy to ball B. Ball B is transferring its energy to ball A. After this transfer is complete, we move to the right side of the equation, which is the after impact equation, where ball A is traveling back this way, ball B is traveling this way, because they've collided and they've separated, just like you would see with any collision. Alright, so you may say, why do I need to know this? What's important about elastic collision? You might not know that elastic collisions occur in everyday life. For example, subatomic particles. If you're a scientist or if you study any type of chemistry, you know that molecules bounce off each other constantly. Scientists use these molecules bouncing off each other to create certain energy. It can create energy, it can create explosions, any type of thing through subatomic particles. Also vehicle collisions. Two vehicles collide, that's an example of an elastic collision. Insurance companies can use data collected from crash scenes to determine who's at fault during an automobile crash. In golf and baseball, you swing a bat or you swing a club, you're transferring the energy from your swing to the ball.
Rieri, first pitch and Cruz drives one deep to left field. That's headed toward Grand Prairie. Goodbye.
Also in football, if you're running, two people are running full speed at each other, at one person is one mass, one person is another mass, and they're going at different speeds, they're going to collide. Whoever has the most momentum is going to drive the other person back. And also, Game 7 of the finals. Game 7 of the finals, you might say, well, you never know. You get a pass, you get a steal, you lay it up off the backboard, you got somebody coming to dunk you. You win the game. Hey, you never know what could happen. If you don't throw that ball off the backboard at the right angle and the right velocity, well, let's just say you could be in for a very, very depressing and humiliating press conference.